All right, here we go on section 3.4. Today we're going to be talking about triangles. Now, triangles, as the name implies, states that it is a figure with three angles. Just like a tricycle has three wheels, a triangle here is going to have three angles and three sides. Now, on the first page, you should have researched that there are specific types of triangles, and you want to become familiar with the names of those triangles. For now, the first part of the notes here state that we are supposed to state whether a triangle with two angles having the given measures is acute, right, obtuse, and compute the measure of the third angle. Now, based off this, and hopefully have your notes handy, because obviously those terms are going to be important, I actually think it's important with a problem like this to go ahead and take a look at a drawing. Okay, it'll help guide us. And then if you notice, I have this written twice. I want it to be a good reminder, knowing that the measure of one of my angles plus the second angle plus the third angle with the triangle is always 100% of the time going to be equal to 180 degrees. That's something that I can use pretty consistently with triangle problems to help me find the right answer. So looking at the first angle here, I'm going to go ahead and arbitrarily choose 55 to be angle 1, okay, and just say that that is 55, and 2 to be 43. Now, if you notice, I have one triangle here that I'm going to use for all the problems. It obviously is not to scale, but as long as I label it properly, we should be fine. So we take a look, and the measure of angle 1 in this particular case is 55 degrees, plus the measure of angle 2, I said, was 43 degrees. Plus the measure of angle 3, I don't know what that one is. That's what I'm looking for. The third angle is equal to 180 degrees. Now I can combine these two together, and I get that this is 98 degrees plus the measure of angle 3 is equal to 180 degrees. I subtract 98 degrees from both sides. Again, trying to isolate the measure of angle 3. Okay. When I subtract those, I get down here to the measure of angle 3 is equal to, probably shouldn't have crossed that out entirely, but it is equal to, 82 degrees. Okay. Now, looking at this, if you look back to your notes, if we have three acute angles for the triangle, then we actually just call the triangle itself an acute triangle. All right. Now, I'll leave the next few numbered ones to you. However, I know that when we go in here with a variable, it becomes a little bit more challenging. So keep in mind, a lot of times when you're going to be solving for a problem that lists variables, you're really not going to be able to do much except to express that last term, or the last angle, in terms of those variables. So once again, I'm going to choose arbitrarily one of the angles to be angle 1 and the second one to be angle 2. Then we're going to take or label it on our diagram, so I have a nice picture of what's going on. Okay, 10 minus 2 degrees, and here we have 60 plus 3t degrees. Now, once again, I'm going to go back to my trusty equation here and say, well, I know that 10 minus t degrees, I'm replacing the measure of angle 1 with what it's equal to, plus 60 plus 3t degrees, plus the measure of angle 3, which again I don't know, is equal to 180 degrees. Now, I'm going to go ahead and combine together like terms. I see here, this is a method that I've used before. I go ahead and I'm going to box all of my t's. If you notice, I boxed the symbol in front too, so I know if they're positive or negative, and I circle the constant numbers. And 3t minus t is going to give me a 2t, and 10 plus 60 is 70. Plus the measure of angle 3 is equal to 180. Keeping in mind that, again, I'm solving for the measure of angle 3, I need to get rid of everything else. I'm going to go ahead and subtract the 70 first. Take it one step at a time, plus the measure of angle 3 is equal to 110. Okay. Now, I'm not going to divide here. I want to get this 2t all over to the side. And I know some of you were thinking I was going to divide. So all I want to do is cancel the 2t. I'm going to subtract 2t from both sides. I don't have any like terms over here. So all I do is write the measure of angle 3 is equal to 110 minus 2t. Okay. Now, based off of this, there's not a whole lot that we can assume as far as determining if it's acute, right, I'm off the page, if it is acute, right, or obtuse, simply because we don't know the numbers. However, I think that we can certainly assume that it is not an equilateral triangle at this point, and to be honest, not a whole lot else, right? And if anyone thinks that they can determine it, please let me know. I'd love to learn from you, but I don't see a way personally myself right now. So we can say that the missing angle, okay, was in fact the measure of angle 3 as we defined it is equal to 110 minus 2t. Now, moving on to the next problem here. Hey, I'm going to go ahead and I'm going to utilize the theorem. So if you look back in this particular case to theorem 312, what it states is if we want to find the measure of A, I'm going to go ahead and put an X there. The measure of the two remote interior angles, simply meaning that they're really far away from the 120. They're not adjacent to the 120. Okay, the measure or the sum of these two, so 80 plus, well, and actually I can call it X or I can just call it the measure of angle A, and I'm going to change my mind and call it the measure of angle A, is equal to 120 degrees. Okay. Now, if we subtract 80 from both sides, we can easily say or see that the measure of angle A is in fact equal to 60 degrees. Now, one of the things that I want you to notice is this is not even close to the only way to do this. And in fact, if you want to memorize less theories or theorems, you can see that 120 plus this angle here needs to add up to 180, meaning that this angle has to be 60 degrees. Okay? In which case 60 plus 80 is 140, meaning that I subtracted wrong over here. Hope someone caught that. There we go. Meaning that 60 plus 80 being 140, the last angle here would have to be 40 degrees. So as we see, a lot of the theorems aren't really necessary. They just make life a little bit easier, and you have to do a little bit less work yourself. Okay? So again, here, I'm going to go back, and I'm using a little bit of scratch paper simply because I want to be able to show all of my steps. Okay? And I can see here that if I call this angle 3, okay, then I can go back to my original statement that if the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 must equal 180 degrees. And in this statement here, well, we have the measure of angle 1, we can just say is 80 degrees. The measure of angle 2 is 50 degrees. And the measure of angle 3 we don't know. That's what we're trying to find. That's equal to 180 degrees. Combine these together, I get 130 degrees plus the measure of angle 3 is equal to 180 degrees. Subtract 130 from both sides. And we find that the measure of angle 3 is in fact equal to 50 degrees. Now, you might ask, why did I go ahead and find the measure of angle 3 here, when really I'm trying to find A? Well, the reason is, if I find that this is 50 degrees, well, then what does this one have to be? These are vertical angles, so this would also have to be 50 degrees. Since this is 50 and this is 50, I know that I can have 50 plus 50 plus the measure of angle A must equal, you guessed it, 180 degrees. A little bit of algebra, a little bit of adding, and I get 100 plus the measure of angle A equals 180 degrees. Subtract 100, subtract 100, and I find that for my final answer here, the measure of angle A must in fact equal 80 degrees. As you can see, I've been utilizing and will continue to utilize this particular statement over and over again, and I simply plug in the angles that I find, okay, and then solve for those that I'm looking for. And I combine that with the other theorems, and again, you don't have to use the new theorems necessarily. Use the ones you like. Use the ones that are comfortable to you, okay, to find that additional information I might need. Right? Now, moving on. If we take a look at this next section here, and I'll leave the second section here for you to try, but again, don't let those x's scare you, right? Now, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, doesn't matter what triangle you're talking about, but we're looking at this particular one here, well, we know that has to equal 180 degrees. Now, if the measure of angle 1 is equal to the measure of angle 2, which is equal to the measure of angle 3, then each of the three angles measures, well, if this is equal to this, which is equal to this, then we can go ahead and make a statement. Even if we don't know what it is, x plus x plus x, we know they're all the same value is equal to 180 degrees. Well, x plus x plus x is just 3x, which is equal to 180 degrees. Divide by 3, and we get that x is equal to 60 degrees. This is an equilateral triangle, and an equilateral triangle will always have angles that measure 60 degrees. It doesn't matter how big or small the triangle is. It will always have those same angles. Okay. Okay. Now here, the measure of angle 4 is equal to the measure of angle 2 plus the measure of, okay, and I'm actually going to leave this one to you, but I will give you a hint. For this one, you're going to want to take a look at Theorem 3-12. Okay, there's a special deal. Or you could use our straight angles and get there by a different method. It's entirely up to you. Leave 4 and 5 and 6 to you. Again, with these two here, please don't be scared. Start with the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180, if that's the best theorem. Okay? But in general, that's going to be a good start. Okay? Sometimes with these exterior angles, we're going to want to look at our other theorems. But just take a look at the theorems. Look for relationships and get there in a method that works for you. Okay. Now, this one here, okay, if we take a look and again apply our same method, we can see that x degrees, well, I feel like I'm probably going to want to know what, I can find this angle. Looking at it, I'm hoping you can realize that that's the only angle you can find. So we're going to use that same formula once again. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Okay. And we will see that this angle, if I go ahead and call this angle 3 once again, well, I have 50 degrees plus 60 degrees plus the measure of angle 3 is equal to 180 degrees. Combine these together, I get 110 plus the measure of angle 3 is equal to 180 degrees. Subtract 110 from both sides, and we find the measure of angle 3 is equal to 70 degrees. Now, you might ask, Mr. Cooley, well, what do I do with that now? Well, let's go ahead and use a method that we've used before. I'm just trying to find x, so I'm actually going to cover up everything else. Because I'm seeing a line there, I feel like there's something I can do with just what I have right there. And in fact, 70 plus x must equal, hopefully right now I'm here, or a lot of people are saying to themselves, 180 degrees. That is a straight angle according to the angle addition postulate. Okay, we can now see if we subtract 70 from both sides that x must in fact equal 110 degrees. Okay, So let's fill that information in. I'm not entirely sure we're going to need it. Now, hopefully you're getting the idea that we always need two of the three angles. Okay? Not always, but unless we have additional information, that's generally what we're looking for. Right now I have one angle and then one unknown, and I need to find out what this is. But I can see that 70 probably has a relationship with this. That's my favorite type of angle, a vertical angle. So once again, formula, hopefully you're getting sick of it by now. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to equal 180 degrees. Here I see that the measure of angle 1 I can just say is 45 degrees. Again, you can switch these up any way you like. I'm just choosing the measure of angle 1, measure of angle 2, measure of angle 3 at random. It really doesn't matter. Plus 70 degrees plus y for the third degree is equal to 180 degrees. Now, if I go ahead and combine these together, I get 115 degrees plus y is equal to 180 degrees. Subtract 115 from both sides, and we find that y is equal to 65 degrees. Now, for the next problem, I'm actually going to leave this one to you too, because I think we're getting some confidence, and I think that we know how to tackle a problem such as this. But one hint that I am going to give is to take out your highlighter. Okay? And again, get laser focused on these two parallel lines. So now I know I have those two parallel lines. I can see that I have a couple different transversals here. Okay. And you know what? I'm feeling generous. I'll go ahead and walk us through x, finding x. So if I extend this transversal out, and then I'm probably going to want to go ahead and take out a little sheet of paper and just cover up this section. I don't really want to deal with that quite yet. Well, I know that these two lines here are parallel. Okay, and I can see that I have a transversal running through here, so I'm pretty confident x and 60 do have a particular relationship. Okay, take a moment, see if you can remember what it is. They're both on the interior of the lines, and they're on alternate sides of the transversal. So x and 60 are, you guessed it, alternate interior angles, meaning that x is in fact equal to 60 degrees. Okay, I can fill that in here. Now for the next one, we have a couple different things we can do. One, you could utilize the fact that you know this is perpendicular, so there's a theorem telling you how much this is going to be, but we just learned something about our triangles, and I'm way too generous today. Call this angle 1, this angle 2, this angle 3, and see if you can figure it out. Okay, and as we are no longer, whoa, lost the lights. Whew, energy efficiency at work. All right, so as I know we're not going to be really assessing the proofs in the future, I would like you to do a little bit of practice. I did a pretty good amount of these notes for you, and I think we're going to be in good shape. See what you can do with the proof. We'll go over it in class. Okay, write down questions you might have. Love questions, okay? And this will conclude the section 3.4 video on triangles.